And please.
Hello everyone, I am Shahnaz and I am studying in Baku State University as a PhD student, and our paper is called nucleon-Roper transition for factors in hydro AdS QCD model. And my supervisor name is Professor Shahnaz. And I said when define important factor in the framework of AdS QCD model. What's AdS? As non-visitor space-time is a solution of the Einstein equation. Unvisitor space-time is scalar curve is negative and constant, and it has a boundary. And we can also see this or I can say negative curve in the middle of the pictures. And AdS QCD model is based on AdS correspondence. AdS correspondence is one of the important discoveries in modern theoretical physics, and this correspondence is related for dimensional physics to 5-dimensional physics, and this correspondence from time to time is called holographic theory. Roughly speaking, the AdS duality claims this two theory strongly couple 4-dimensional gauge theory and gravitational theory in 5-dimensional, or I can say unvisitor space-time. I'm sorry. And we can also see from the pictures, conformal theory is long in Minkowski space-time, 4-dimensional, and gravitational theory is known in 5-dimensional unvisitor space-time. And much of the usefulness of the duality results from the fact it's a strong peak duality. When the fields of the quantum field theory are strongly interacting, the ones in the gravitational theory are weakly interacting, and that's more mathematical attractive. And we can also AdS see the correspondence from the video. This is a boundary and it's known conformal theory, but this is in the bulk is the known gravitational theory, and this called unvisitor space-time. And more this duality was adapted to describe the low energy dynamics of QCD and called AdS. And it's known conformal theory, but this is in the bulk is the known gravitational theory, and this called unvisitor space-time. And more this duality was adapted to describe the low energy dynamics of QCD and called AdS QCD. There are two approaches in AdS QCD, top-down and bottom-up. The models of the bottom-up and top-down approach are widely applied to predict physiological quantities in particle physics. We define form factor Roper and nucleon transition. We know that photon is not point-like particle. They have internal structure and a starting form factor nucleon is very useful tool for to learn internal structure of hadrons. We can define in the circle process. Then we have to define both the function for nucleon, and we must use quark action for the spinor field as in one expression, and this is Dm. This is Lorentz and gauge covariant derivative, and this is defined in the form. And we can also in the to expression omega n bc. This is spin connection. Another component of the spin connection is defined as straight formula. And then, if we take into account 2 and 3, and it's known complementary, but this is in the bulk is known gravitational theory, and is called anticipator space-time. And more this duality was adapted to describe the low energy dynamics of QCD and called AdS QCD. There are two approaches in AdS QCD, top-down and bottom-up. The models of the bottom-up and top-down approach are widely applied to predict physiological quantities in particle physics. We define form factor Roper and nucleon transition. We know that photon is not point-like particle. They have internal structure and starting form factor nucleon is very useful tool for to learn internal structure of hadrons. We can define in the circle process. Then we have to define both the function for nucleon, and we must use quark action for the spinor field as in one expression, and this is Tm. This is Lorentz and gauge covariant derivative, and this is defined in the form. And we can also in the to expression omega n bc. This is spin connection. Another component of the spin connection is defined as straight formula. And then, if we take into account 2 and 3 expression and matrix expression in one action, we can equation of motion as for formula, and then the Dirac equation will be written as equations for the profile functions, and it's favorable to solve this equation in terms of pre-campaigns as by formula. And if we take into account 5 and 6 formula in for equation of motion, we can say 7 and 8 expression. And extra components of these spinors are eliminated by the UV bound conditions imposed on the spinors. The most agent values of the curves frame models depend on which profile manage their boundary. And solution to the equations 7, 8 are expressed in terms of lesser functions as 9 expressions. And we can see CL constants, and these constants were found from the normalization conditions. Then, we can see this is the mass spectrum of the causal claim models corresponding to the ground and excited states of the boundary nucleons. Then we have to write vector field, or I can say bulk boundary propagator, and in order to define the profile function in vector field, we must write action 5-dimensional vector field, action as 14 expression, and the usual gauge fixing of the fifth component is the axial gauge, we set real 0, and Fourier transform of the vector field will be written as 15 expression, where the bulk to boundary propagator obeys the equation of motion, and obtained from the action 14 action, and impose the boundary conditions yes. And when is the boundary value of the free vector field, and the solution of the equation 16 is written in terms of the Bessel function as 17 expression. Then now we define Dirac and Pauli Coulomb factors and hence the amplitudes, Roper nucleon for Roper nucleon and nucleon transitions. In order to obtain Coulomb factors, Roper nucleon and nucleon transitions within the framework of the holographic QCD, we have to write an action as 15 expression, and interaction is the Lagrangian interaction between spinor and vector fields as 9 expression. And then here our string is a spinor matrix, and this is copy constants. And as known, according to the AdS correspondence of the bulk and boundary theories, the generating functionals of the gauge and AdS gravity theories are equivalent, and now the vector count of nucleons, which is defined in QCD theory, can be calculated can be calculated using the correspondence this equality and generating functions that AdS is defined as an exponent of classical quark action and as 21 expression. And we know that the vacuum extraction value of the nucleons, vector current in the boundary QCD theory will be found applying the holographic formula as following. And the electromagnetic current of the Roper nucleon transition as are defined as a Euler form and Y23 and F1 Q square and F2 Q square are called Dirac and Pauli form factors. If they compared to 23, if we take into account agent action in 21 expression, we can define the AdS generating function, and then we can define the vacuum extraction value of the nucleon vector current. Then we compare the vacuum extraction value of the nucleon vector current to electromagnetic current of the Roper nucleon transition, and then we define these integral expressions, and we here found two straight sums give us F1 Q square or weight factor. Here 4 give us all form factors, and this form factor are normalized to the electric charge and anomalous magnetic moment of nucleon. And this form factor, by definition, particle has an electromagnetic structure, is not a one particle. The functions are not constant. The functions are close charge or moment form factor of the nucleon respectively. Then we can define A, Q, and S, Q square heads with amplitudes within the Pauli and Dirac form factors. As following. The results we now our results is presented in figure 1 and 2, Pauli and form factors, and we compare our results to non-relativistic quark material and class and made experimental data. We can see now from the figures our results is presented red within red lines plus experimental data to squares with error bars made with dashed lines, and green lines is a non-relativistic quark model. Red lines belong to for us numerical results, and we can from the graphs our results are close experimental data. Especially, I want to emphasize that plus experimental data. and multi-experimental data for Dirac following Upper and Pauli following but we see the amplitude the hardware results for AdS square is amplitude for this transition are given in figure 3 and 4, and the graphs of these amplitudes are close to the experimental data at some points. Yes, at some points. But Dirac and Pauli factors are close experimental data migrant class, but elicited amplitudes are close at some points. Red line to us. This is class experimental data. Square is 0 bars and made dashed lines, green lines linked to nonrelativistic quark.
Okay, thank you very much, Dr. Taghiyeva, for your nice presentation.
Thank you for your attention.
And thank you, all of our audience. And right now, this session will be terminated, and after